guys, today we are going to continue working in Chapter 5, Section 3, just having a second day to look at how you can solve trig equations. Again, you will need to use your unit circle, and we are looking for all of the solutions that fall within the domain starting at 0 and going up to 2 pi. Okay, so again, this will be a pretty much review from what we did yesterday. We'll add in a couple new ideas. I'm hoping you did have a chance to look at some of the suggested assignment as well as join me on the Zoom call. But the more that you see this, the easier it's going to be for you. So let's go ahead. If you have your trig function already isolated, like we have here, this says the sine of x equals the square root of 2 over 2. You just have to remember that the sine is the y value. So what it's asking you is on the unit circle, from 0 all the way to 2 pi, where is the y value equivalent to the square root of 2 over 2? And so when you think about the y value tells you up or down. So we know we'll be traveling upwards. We see that the y value is the square root of 2 over 2 at pi over 4. So that's one solution. The other location where the y value is a positive square root of 2 over 2 is at 3 pi over 4. So those are your two solutions. X equals pi over 4 and x equals 3 pi over 4. And that's all you would have to do for number 1. Okay, now looking at number 2. This is already isolated. The tangent of x equals 1. So again, this means where on the unit circle can you find the tangent, which is y divided by x, where would that equal a 1? So what you have to realize is that when you divide two things that are the same, you end up with 1. So we're looking on the unit circle, where are both our x and y value the same? And so here, pi over 4, both of them are the square root of 2 over 2. So if you take square root of 2 over 2 divided by square root of 2 over 2, you're going to get 1. So one solution will be pi over 4. The other quadrant I'm going to look at is in quadrant 3 because both of the signs would be negative, allowing me to match my x and y exactly. Because negative divided by a negative would give me the positive. Square root of 2 over 2 divided by square root of 2 over 2 is 1. So my two solutions for number 2, x equals pi over 4. And our second location was x equals 5 pi over 4. Okay, now number 3 is the same idea, but this is called a multiple angle. And so what you're going to do is find places on your unit circle where the cosine is equal to 1/2. Again, the cosine is the x value. The x value tells you if you're going right or left. We're looking for a positive value, so we know it'll be on the right half of the unit circle. But instead of saying that x equals that radian measurement, we have to state that 2x equals that radian measurement. So again, we'll start off, where is the cosine 1/2? Again, I'm looking at the right side because my cosine has to be positive. So I have pi over 3 and 5 pi over 3. So the way that I'm going to write this, because it's 2x equals pi over 3 and 2x equals 5 pi over 3. Now the goal here is still to solve for x. When you solve for x, that means that you isolate it. So I cannot leave it as 2x. I need it to be just x. So what I need to do is divide both sides by 2. Well, if you're dividing fractions, that's the same thing as multiplying by the reciprocal. So if I divide by 2, that is the same thing as multiplying by 1/2. And the same thing is going to end up happening on the other side. So in order to find my two solutions, what I need to do is cancel the 2. So I'd have x equals, when I multiply by 1/2, pi times 1 is pi. 3 times 2 is 6. So x equals pi over 6. Here, in order to cancel the 2, I'm multiplying by 1/2 because that's the same as dividing by 2. 5 pi times 1 is 5 pi. 3 times 2 is 6. Those are your two solutions. So there's an example of what's called a multiple angle. It just means that you have a number or a value that is connected to the x. So you cannot just quickly state the two solutions. You need to take whatever this is, and in our case it was a 2x, equals our radian measures and solve from there. Number 4, this time I have a trinomial. If you have a trinomial, this is where you'll be factoring. I do have a number in the front. There's 1, 2, 3 terms, so I know it's the multiply add method. I take the first number and I multiply it by the last number. Positive 2 times negative 1 is negative 2. You add to the middle, which is a negative 1. So my two values would be negative 2, positive 1, because negative 2 times 1 gives me that negative 2. Negative 2 plus 1 is negative 1. Because there's a number in the front, these two values replace the middle term. The middle term contains a sign, so I have to make sure that these both have sine of x as well. So that brings me to 2 times sine squared of x. Now I'm going to start filling in those values. Minus 2 times the sine of x. My 1 is positive. So plus 1 times the sine of x. Your last term never changes. So notice your first term and your last term stayed the same. I found my two values. They replace the middle term. At this point, I have 4 terms. If you have 4 terms, you want to factor using what's called the grouping method. If I look at the first 2 terms, they both contain a 2 and a sine of x. So I can divide out 2 sine of x. What I'd have left is a sine of x minus 1. This is already 1 sine of x minus 1. It matches. So I don't want to change it. If I want to keep the same value, you're going to have to divide out a positive 1. Because remember, with grouping, you always have to divide something out of each group. If it already matches, you would just take out a positive 1. Whatever you divide out, that forms a group. So 2 times the sine of x plus 1. What you have in common. In our case, it's a sine of x minus 1. That's the second group. Now this is factored, and what we looked at yesterday is once you have your equation factored, what you can go ahead and do is take each factor separately and set it equal to 0. And so that's what we're going to go ahead and do now. So 2 times the sine of x plus 1 equals 0. Sine of x minus 1 equals 0. From here, you isolate your trig function. So I'm going to minus 1, then divide by 2. So the sine of x equals negative 1/2. Now that I've isolated the trig function, now it's time to look at the unit circle. The sine is the y value. Where is the y value? A negative 1/2. Remember, y tells you up or down. We're looking at a negative value, so it's going to be on the bottom portion of our unit circle. So we're looking for y to be negative 1/2. So I see that at 11 pi over 6 as well as 7 pi over 6. So x equals 11 pi over 6 and x equals 7 pi over 6. Now those are the solutions from that factor. Now I'm going to come over here. I need to isolate the trig function. The way to do that is I take my minus 1 and I add it to the other side. 0 plus 1 is 1. I need to look at the unit circle and say, okay, where does y equal 1? There is one location, and that's right at the top of the unit circle, our 90 degrees, which is pi over 2. So x equals pi over 2. So we had 3 solutions for number 4. All right, let's keep going, guys. If I look at number 5, one of the rules that they told us yesterday is if you have trig functions on both sides of the equal sign, you do always want to start off by moving them together. You want all of your trig functions on one side of the equation. So I'm going to take this cosine of x and move it over. So now it would look like this. Cosine cubed of x minus a cosine of x equals 0. Now my cosines are on the same side. If you can factor it, that's what you always want to do. This is a nice quick one. This has a cosine, this has a cosine. Here I can just divide out what they have in common. If I had 3 cosines and I take one out, I am down to 2. Minus cosine of x divided by cosine of x is 1. So this is factored. Now you take each piece. What you divided out, cosine of x, set that equal to 0. what you had remaining, cosine squared of x minus 1, set that equal to 0. Here, my trig function is already isolated, so I can go to the unit circle. The cosine is the x value. We are looking at where is the x value equal to 0. Well, the x value is equal to 0 at two places, pi over 2 and 3 pi over 2. So x equals pi over 2 and x equals 3 pi over 2. Now if I come over here, I need to isolate the cosine of x. So step 1, I'll add 1 over. So I'd have cosine squared of x equals 1. To cancel a power of 2, you need to take the square root of each side. When you cancel a power of 2 by taking a square root, you do need to include both the positive and negative. The square root of 1 is 1. So now I'm looking on the unit circle. Where is the cosine, which is the x value? Where is the x value, a positive or a negative 1? Well, the x value is a positive 1 at 0, and the x is a negative 1 at pi. So that adds two solutions to the equation, 0 and pi. So x equals 0, x equals pi. There are my four solutions to the equation, cosine cubed of x minus the cosine of x equals 0. Next one. Again, what they're going to do here is give us something that we can factor. Looking at number 6, I am subtracting two terms that both contain a sine function. So when I look at this, I can go ahead and divide out what they have in common. They both have a sine of x. Well, sine of x divided by sine of x is 1. Minus 2, I'm taking the sine of x out, so it would be gone, leaving me just a cosine of x. So I divided out the greatest common factor. Once you have done that, now you can take each piece. What I took out, set that equal to 0. What you had left on the inside, set that equal to 0. Now it's time to go ahead and try to get our trig functions isolated. Here it already is. I know that the sine of x equals 0. The sine is the y value. So in the unit circle, we have to look and say, okay, where is y equal to a 0? Meaning you're not going up or down. Well, that happens at two places, at 0 and at pi. So I have two solutions already, x equals 0, x equals pi. Now I have to isolate the trig function here first. So my first step is I'm going to take this 1 and minus it to the other side. So negative 2 times the cosine of x equals a negative 1. Now I need to divide negative 2 over. Cosine of x would equal positive 1/2. It now would be positive because this was a negative 1. What I'm really doing here is dividing that negative 2 over. So negative divided by a negative would give me the positive. The cosine is the x. So what I'm looking for on the unit circle is where is the x value 1/2? Well, the x value is 1/2 at pi over 3. And the x value is 1/2 at 5 pi over 3. So I'm adding two solutions. X equals pi over 3 and x equals 5 pi over 3. So again, for number 6, we do have four solutions. Let's move on and try to battle out number 7. Now number 7 is another one we can factor. And I know that because if you look at it, there are 1, 2, 3 terms. If you have 3 terms, it's a pretty good chance that it's kind of a hint telling you, hey, you're doing the multiply add method. And that is what we're going to go ahead and do here. So multiply add method, there is not a number in the front. So you are trying to find two numbers that multiply to the end, meaning negative 2, add to the middle, negative 1. Numbers that multiply to negative 2 and add to a negative 1 are negative 2 times 1. Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. Because there's not a numerical value in the front, we don't have a coefficient there, I get to simply just write my cosecant of x with these values. So it's cosecant of x minus 2, cosecant of x plus 1 equals 0. So now I can go ahead, take each factor, set it equal to 0. Cosecant of x minus 2 equals 0. Cosecant of x plus 1 equals 0. solve for the trig function. Isolate that. So if I add 2, cosecant of x would equal 2. Here, if I minus 1, cosecant of x equals negative 1. Now, a cosecant is not a value that we can quickly get from a unit circle, but we know the reciprocals. The cosecant is the reciprocal of the sine. So if I am doing the reciprocal of 2, I would have 1/2. So the cosecant of x equals 2 is the same thing as the sine of x equals 1/2, because cosecant and the sine are reciprocals. 2 and 1/2 are reciprocals. Same thing here. The cosecant is the reciprocal of the sine. So I can write it as a sine function, take the reciprocal. The reciprocal of -1 is -1. Now this is the format where I can quickly look at the unit circle. I know that the sine is the y value. So where is my y value? Positive 1/2. We'll look at first. So y is positive 1/2 at pi over 6, and pi is positive 1/2 at 5 pi over 6. So we have x equals pi over 6, and x equals 5 pi over 6. Now our other solution, we're going to find when the y value is equal to -1. That only happens one time on the unit circle. If you look all the way around, the y value is only a -1 at 3 pi over 2. So there is my third solution. 3 pi over 2, and we are done. So right now, these 7 questions that we have done so far, it's a pretty darn good review of what we did yesterday. We have not added in any new ideas yet, okay? Now, starting at number 8, I'm going to show you some new techniques that hopefully show you, in some cases, it's going to make it a little bit easier. In some ways, it's the only way that you can solve, is if you can try this new process, okay? So number 8 and number 9, what's going to happen, and you'll notice it says new idea. Rewrite with a single trig function using identities. Now, we have had a couple examples where you did have more than one trig function. Like even if I look at number 6, I had both sines and cosines, okay? But there are times where you might look at it and say, I just want to deal with one. If that's the case, you can use your trig identities. Now, when you see a sine or a cosine and you have a power of 2, by now, hopefully that gets you to the idea of sine squared of x plus cosine squared of x equals 1, because that is a huge identity that we've seen throughout this entire chapter. Okay, so seeing that cosine squared of x, I know I can turn it into a function or a value pertaining to just the sine by rearranging that. So what I need to do is minus sine squared of x over here. So cosine squared of x equals 1 minus sine squared of x. By doing that, I see that these two things match. So rather than writing cosine squared of x, I'm going to replace it with 1 minus sine squared of x, because they have the same value. They mean the same thing. Equals 1 minus the sine of x. Now if I look, it's a little bit more friendly because I only have the sine function. But you want it set equal to 0. I typically, if I can avoid it, I don't like having a value, even if it's just a negative in front of my squared term. So when I go to set this thing equal to 0, I'm going to move both of these terms to the other side. So I would have 0 here, negative sine squared of x, it's negative on this side. So when I move it over, it's going to be a positive sine squared of x. I'm putting this in standard form, so this has 2 x's, okay, it's 2 of them. This has 1, so my minus sine of x, it's still a minus because I kept it here. Now, in order to move this 1, I had to minus it over because it was positive 1 here, so if I minus it, it actually cancels. So here's my new equation. They both have a sine in common, so I can take out the greatest common factor, and this is what it would look like. Now you take each piece. The sine of x, set that equal to 0. Sine of x minus 1, set that equal to 0. Here, my sine function is already isolated. I want to know on the unit circle where is y equal to 0. Well, that happens in 2 places, 0 and pi. So there's 2 solutions. X equals 0, x equals pi. Now when I look at this factor, I need to first isolate the trig function. So I add 1. 0 plus 1 is 1. So now I need to look at the unit circle. The sign is the y value. Where is the y equal to 1? That is located at pi over 2. So there are my 3 solutions for number 8. And that was our first one that kind of had a new idea going into those trig identities. Okay, just in case that was a little bit tricky, we're going to do the same idea for number 9. It says new idea, rewrite with a single trig function. Okay, where you're going to be able to use those properties is where you have a power of 2. So again, it's sine squared of x. So it's that same property we just looked at. Sine squared of x plus cosine squared of x equals 1. I need to get this by itself so that way I can substitute in a cosine. So what I'd have to do is minus cosine squared of x over. Sine squared of x equals 1 minus cosine squared of x. So now I can come up here in number 9, and where I have sine squared of x, I can substitute in 1 minus cosine squared of x. So let's do that. I have a 2. Instead of sine squared of x, we are substituting 1 minus cosine squared of x, plus, I still have everything else the same. 3 times the cosine of x minus 3 equals 0. So notice the entire equation stayed except for the sine squared of x. The 2 stayed. The plus 3 times the cosine of x, the minus 3, and the 0. I have to cancel the parentheses. So we do have to distribute that 2 in. This is 2 minus 2 times the cosine squared of x plus 3 times the cosine of x minus 3 equals 0. Now what I need to do here is combine like terms. 2 and negative 3, they're constants. They're just numbers. I can combine them. I do want this in standard form, so I am going to make sure that I have my minus, there we go, like that's safe, minus 2 times the cosine squared of x first, because this is an exponent of 2, plus 3 cosine of x, 2 minus 3, when I combine them, I would have a value of negative 1. 1, 2, 3 terms, multiply, add method. There is a number in the front. It's my really funky looking 2. Negative 2 times negative 1 is positive 2. So I need 2 numbers that multiply to 2 and add to 3. So that's a 2 and a 1, because 2 times 1 is 2, and 2 plus 1 is 3. Because of the number in the front, these two replace the middle. The middle term has a cosine, so I need to make sure that I do have 2 times cosine of x and 1 times cosine of x when I put them in the middle. The first term stays, negative 2 cosine squared of x, plus 2 cosine of x, plus 1 cosine of x minus 1. Again, notice your first term and your last term do not change. Your 2 and your 1, they go right in the middle. 4 terms. You're going to go ahead and do the grouping method. I don't like a negative out front here, so I'm going to take out the negative for sure. Both of these terms have a 2. They also both have a cosine of x. So I'm taking out the negative 2. I had 2 cosines. If I take 1 out, I'm down to 1. Positive divided by a negative is going to change that to a negative. The 2 is gone. The cosine of x is gone. When everything is gone, it's a 1. These two things already match because a cosine of x is the same thing as 1 times a cosine of x. So I'm going to take out a 1 so that way I don't change it because I need these two things to match. What I took out was a negative 2 times the cosine of x plus 1. What they have in common is a cosine of x minus 1. Now you set each group separately equal to 0. Negative 2 times the cosine of x plus 1, set that equal to 0. Cosine of x minus 1, set that equal to 0. Now you solve the equation by isolating the trig function. So here I would minus 1 and divide by negative 2. If I minus 1 and divide by a negative 2, I would end up with a positive 1/2. Cosine is the x value. So my x value is 1/2 at pi over 3 and 5 pi over 3. Pi over 3, 5 pi over 3. Okay, now I go to the second factor. If I add the 1 over, cosine of x equals 1. Where is the x value equal to a 1? add 0. There are your solutions for number 9. You should have pi over 3, 5 pi over 3, and 0. Okay, and again, I know this is it's a lot. It's different ways you can do identities, and it's factoring, and it's unit circle. But today is just one of those days where you are just processing. So we are just going to go ahead and do these 13 questions together. We have 4 left. You do not have a suggested assignment today. Today is just watch through the notes, and then tonight, sleep on it. And tomorrow when you work on the worksheet, I think you're going to be just fine because you'll have 2 days plus a Zoom call where we looked at this material. But again, there is no assignment. Today is just to watch this video and kind of absorb what's going on, okay? 10 and 11 give us another new idea. If I look at number 10, right now I'm like, all right, what do I do? Because first off, I have 2 trig functions. I have a sine and I have a cosine. I can't use an identity the way that it is because if you think of our Pythagorean identities, they all have a power of 2. So if you can have one trig function by itself, like we have here, we have the sine, you can square both sides, and what that's going to do is make it so we can have a trig identity. So if I square both sides, yes, I am going to have to FOIL this, okay? Cosine of x plus 1, cosine of x plus 1, because I squared a binomial, meaning now I have it twice. Cosine of x times cosine of x is cosine squared of x. Cosine of x times 1 is cosine of x. 1 times cosine of x is cosine of x. 1 times 1 is 1. So on this side, I can combine my like terms. 1 cosine of x and 1 cosine of x. I have 2 cosine of x. That's what the left side is. Now, if I take the sine of x and I square it, it is just sine squared of x. Now, here's where I can use that identity. Because if I go ahead and I use sine squared of x plus cosine squared of x equals 1, which we have used so many times already today, I can replace this side with 1 minus cosine squared of x because it means the same thing. Now this side is already all cosines. So now it's going to be a little bit easier because my entire problem is just cosines. So again, if you have a problem where you do have more than one trig function, what you can do, you want to isolate a trig function first if you don't have that. We had that here. We had a sine of x. You square both sides because it will create something that we can use a trig identity. On this side, it created sine squared of x, which in turn can be replaced with 1 minus cosine squared of x. Now what I need to do is set this thing equal to 0. So I need to add cosine squared of x to each side. I'm going to minus the 1 on this side, so that way this all cancels, this side is a 0. Cosine squared of x plus cosine squared of x, I have 2 cosine squareds of x. Plus I have 2 cosines of x. Positive 1, negative 1 cancels. Here's my new equation. This one, if you look at it, they have things in common. So I can go ahead and just divide out the greatest common factor. They both have a 2 and a cosine of x. If I take out the 2, and I take out 1 cosine of x, I would have 1 remaining. Plus 2 cosine of x divided by 2 cosine of x, you're going to get 1 because it's the same thing. Now it's factored. So you can take each piece separately and set it equal to 0. Well, here, if I set this equal to 0, if I divide by 2, 0 divided by 2 is 0. Cosine is the x. So where is the x value equal to 0 on a unit circle? At 2 places, at pi over 2 and at 3 pi over 2. So x equals pi over 2 and x equals 3 pi over 2. Now here I have to isolate the trig function, so I need to move 1 over. If I'm moving 1, this is a plus 1, so I have minus 1. 0 minus 1 is negative 1. Again, the cosine is the x value in a unit circle. Where is the x value equal to negative 1? Well, that happens at pi. So there are your 3 solutions. Pi over 2, 3 pi over 2, and pi. So again, one more way that you can solve for a trig equation. Again, because it is new, I want to do a second one. So number 11, it's the same thing, okay? It says new idea. You want to square both sides so that way you can create one of those identities. Here's the difference between number 10 and number 11. Number 10, we already had a trig function isolated. 11, I do not. So what I'm going to do is take this cotangent of x and minus it over. So I'd have cosecant of x equals 1 minus cotangent of x. And it really would not matter which function you subtracted over. So if I would have wanted to, I could have minus the cosecant of x to the other side and we'd still get the same solution. Okay, so if you're wondering, why did I subtract the cotangent? Just the one I decided to move over, okay? Now, in order to create a power of 2, so that way I could use one of those Pythagorean identities, you need to square. So if I square both sides, this becomes cosecant squared of x. This is 1 minus a cotangent of x 2 times. So 1 times 1 is 1. 1 times a negative cotangent of x is a negative cotangent of x. Negative cotangent of x times 1 is a negative cotangent of x. Last, negative times a negative is a positive. Cotangent of x and a cotangent of x give me cotangent squared of x. So what I'm going to do here is put it in standard form. My cotangent squared of x, I'm going to take this first because it has the highest exponent. These are like terms. They're both a single cotangent with x. Negative 1 and negative 1 makes negative 2. Cotangent of x plus 1. Now I can turn this into a cotangent. I'm looking for cosecant squared of x. This is a Pythagorean identity, you guys. If I have a cosecant squared of x, I can replace it with 1 plus a cotangent squared of x. So I'm going to go ahead and do that. This is 1 plus a cotangent squared of x because they are equivalent to one another. So now when I look at the problem, I no longer have two functions. I don't have both a cosecant and a cotangent. I only have a cotangent. But I want this set equal to 0. So I need to minus my cotangent squared of x to each side, and I need to minus the 1 to each side. The 1 cancels. The 1 cancels. This would cancel, so I would have a 0 left over. Okay, so when I go ahead and do that, I had a cotangent squared of x here. If I minus 1 over, this is gone too. So you guys, I have negative 2 times the cotangent of x. Okay, so I'm going to go ahead and divide by negative 2. So cotangent of x equals 0. Now cotangent. Cotangent is the reciprocal of the tangent. Tangent is y divided by x. So I need to know where x over y equals 0. Where can I take the x value over the y value and get a 0? So x over y is 0 here, and x over y is 0 here. So I would have two solutions. They would be at pi over 2 and 3 pi over 2. So again, remembering those reciprocals, the cotangent is the reciprocal of the tangent. Okay, so 10 and 11 just showed you examples of how you could square both sides. That would allow you to use those Pythagorean identities so your equation only has one trig function. 2 more examples and I will let you go for the day. Okay, these are just a couple more examples of multiple angle equations, and the reason why I put a couple more, in the past for some reason this has kind of been a hiccup for some students, so I just want to make sure I show you enough examples where it really makes sense. Okay, so if I'm looking at number 12, I need to isolate the cosine of 3x. Okay, so I'm going to add 1 over and divide by 2. So I would have cosine of 3x equals positive 1/2. It would be positive because this negative 1 would become a positive when I add it over. You start off looking for places where the cosine is equal to 1/2. The cosine is equal to 1/2 at pi over 3 and at 5 pi over 3. So I take 3x equals pi over 3 and 3x equals 5 pi over 3. You're not done because you need x by itself. So what you're doing is you're really dividing by 3, but because this is a fraction, you can't divide fractions. What you're going to do is multiply by the reciprocal, because here 1/3 times 3 is still 1x. Top times top, bottom times bottom, this becomes pi over 9. Same thing here. You need to multiply top and bottom by 1/3 because 1/3 of 3 is just 1x, and I want my 1x isolated. Top times top, bottom times bottom, 5 pi over 9. One more just to make sure we've got it, and then we are done for the day. If I want to isolate tangent of x over 2, I would minus the 3 and then divide by 3. So if I go ahead, I'm just going to make sure that we got this. Tangent of x over 2 if I minus 3. Now if I divide by 3, I'd have tangent of x over 2 equals -1. So you're going to look where the tangent, which is the y over the x, where is y over x equal to -1? Meaning these two things are going to have the same value, but one of them is positive, one of them is negative in order to get that -1. So that's going to happen in quadrants 2 and 4 because 2 and 4 is where you have one positive value, one negative value. Where they are the same is 3 pi over 4 and 7 pi over 4. So it's x over 2 equals 3 pi over 4 and x over 2 equals 7 pi over 4. Again, this is not just a single x, so that's what you set equal to the value from the unit circle. In order to cancel a denominator, you multiply by 2. When you're multiplying by 2, you have to realize that that 2 would go on the top. So this would be 6 pi over 4, which could reduce down to 3 pi over 2. Here again, if I multiply top and bottom by 2, x equals, the 2 goes on the top because it's the same as 2 over 1. This is 14 pi over 4. I can reduce that down to 7 pi over 2. So just 2 additional examples of what are called multiple angle equations. And if you look at this, it says if you understood these 13 questions, you're totally good to go for the whole section, 5.3. Okay, today again is just a day to absorb the material. No suggested assignment. You are done with trig for the day. Thank you so much for watching the video. Tomorrow is a worksheet work day to practice these skills on your own. I hope you guys are having a great day, and I will talk to you soon. Bye.